Okay, guys, Mr. Antonucci here again. So in this video, I want to talk to you about exponential decay, and this is an application of exponential functions. So one of the things that comes up a lot, and we'll get into this more as we go into the year in AP Calculus, is the concept of half-life. And this is the amount of time it takes for half of a radioactive substance to change from its original state to a non-radioactive state. So here is the basic model that includes half-life. You have the amount that remains as a function of time, and that's equal to the amount present times 1/2 to the time in years that has passed divided by the half-life. So A stands for the amount currently present after t years. P stands for the initial amount. This is 1/2. T stands for the number of years that have passed, and H stands for the half-life. So let's do an example. The amount of silicon-32 in a sample would decay from 28 grams to 7 grams in approximately 340 years. What is the approximate half-life of silicon-32, and how much will be present after 500 years? So we have two questions here. What's the half-life, and how much will there be after 500 years? So what we do is we use this model and substitute in what we know. We know that initially there were 28 grams, so the P is 28. It decreases to 7 in approximately 340 years. So that is A of 340 equals 28 to the times 1/2 to the 340. That's our time divided by H, and the answer should come out to be 7. Okay, so we can solve this equation to get the value of H. So first thing you want to do is divide off the 28 just to make things easier. So you have 1/2 to the 340 over H equals 1/4, because 7 divided by 28 is 1/4. Now, if you notice, 1/4 is 1/2 squared. Okay, so I have 1/2 to the 340 over H equals 1/2 squared. That means that 340 over H equals 2. Now, if it doesn't work out nicely like this, like you're not always going to get the other exponent to be 2 or things to be a factor of 1/2, you can always solve this graphically using Desmos or your graphing calculator. Now, if you cross multiply and divide, you would get H equals 170. So the half-life is 170 years. Okay. Now, if I want to know how much is going to be present after 500 years, we could just take out our calculator, clear this off, and you would have 28 times 1/2 raised to the power of, now T would be 500, so 500 divided by H, which is 170. Now, think about this. After 340 years, there's 7 grams that remain. After 500 years, since it's radioactive decay, you would have less than you did after 340 years. Okay, so if I hit enter, you get 3.645. Also, 340 to 500 years is 160 years. That's almost another half-life after it decayed to 7. So if you take the half-life from 7, that would give you 3.5 grams remaining. We haven't gone quite a half-life, and the amount remaining is 3.646 grams. So our answer makes sense in that situation. All right, guys, that's it for exponential decay. Hope that was helpful to you.